Okay. Alright, if you said that you did not get these notes, then whenever I give you guys about 10 minutes to work on the homework, I'll go copy that for you. But there's not too much here for you to look at and work on. So, this lesson today is about the most common statistical software for analysis of data. Yes. So, if you end up going into a business or an industry and you end up doing something on production or prediction or like managing how much you guys are doing in your company, then you will probably be trained in this software called Minitab. And so because of that, then I want you to understand how to read this chart and understand what all these numbers are. Because some of them you need, some of them you don't need, some of them we're going to learn about next semester, and so on. So here we go. First of all, you can tell from this, it's not very descriptive, but this is a problem about trees and something about the volume versus their height. Okay. Now, the next thing that they give you right underneath that is they tell you what the regression equation is. That the volume is negative 87.1 plus 1.54 times the height. And we should know from what we've recently been doing that there is something notation-wise missing from that line. What is it? Prediction hat. Very good. So you need to remember that even though this is not written there, that the prediction hat is missing, and so you understand that this is a predicted a prediction of actual events, not what really is happening. Okay. This next section is actually 5 columns, and each one of these columns has a header to it. So this is the predictor, so it has 2 things underneath it. This column is about coefficients. This column is about standard error of the coefficients. This column is about t-values, and this column is about p-values. Now, these 2 columns we will learn about next semester because they are about inference and inference of relationships and hypothesis testing and all those other stuff. So that, those numbers are there, but you won't use them anytime soon. Now, this first row underneath this predictor column, or this first row, is about the constant. A constant is what? Good. It's something that doesn't change. Okay, so it's a number that does not have a variable with it. And so in our equations, what part of it is our number without a variable with it? The y-intercept, okay, which may be represented by A in your calculator, however you're doing that. So our y-intercept. So this first row is a line about the y-intercept. Okay? And you can see here, look at the coefficient number. Do you see this number? Negative 87.12. Where else have we seen that on this printout so far? In the equation of the line right there. So this value here is the y-intercept in the equation. Okay, very good. Now, the rest of these numbers in the y-intercept line are nothing we will ever, ever, ever be interested in. I'm not sure what industry is interested in this kind of data. I would imagine something is, since the software prints it out. But let's think about it for a second. Remember recently we've done problems and we've gotten y-intercepts and they have just been weird in the context. Like, for example, we may have gotten something that said, at an age of 0, the weight is negative 3.5. Okay, does that make sense? At an age of 0, the weight is negative 3.5. Okay, so we learned that frequently the y-intercept actually does not, what? Make any sense in the context of this problem. Therefore, I don't care how accurate it is, or making any inference with the t-value and the p-value, so we will never use that. Okay, good. The next line starts off with this variable that says height. That is our x variable, and volume is our y. So what do you think this row is about? Okay, the height, and then our coefficients to the x variable is going to be the what? The slope. Thank you. If this first row that's about the constant is the y-intercept, and this second row with the height is about the slope. So everything in this line is about the slope. Okay, and we will use all of these numbers in this line. They're all very important. Slope is very interesting to us because it tells about the relationship between the items. So look here, 1.5433 is the slope in that regression equation. Okay? So that is where that number comes from. Those are the same. All right, this number right here, it's in this column that says standard error coefficient, but it is more frequently actually called the standard deviation of the slope. For right now, I actually don't want to go into the idea of what that is yet. We're going to do that later this class period. I want you just identifying its location. So this is the standard deviation of the slope. Okay. This t and this p-value we'll use next semester. This s is another standard deviation. It is not the standard deviation of the slope. This s is the standard deviation of the residuals. And again, later this class period, we will actually think about these items conceptually and what they mean. But for right now, we're just identifying their location. So the standard deviation of the slope is here. The standard deviation of the residuals is here. Okay. Next, r squared. So what is this r squared value? Good, that is our coefficient of determination. Okay, so that is going to be our coefficient of determination. And notice they do not actually write for you anywhere the r value, which is the correlation coefficient. So we can get the r value from this. How could we get the r value from this r squared? Square root it. Very good. Now, if you remember in your other math classes that when you take a square root of something, there is a positive and a negative root. Can you remember that? There's a positive and a negative root when you take the square root of something. So when I say that the r value is 0.598, I have to think about what is its sign. It doesn't automatically show me the sign when it does the square root in my calculator. So how do you think that I can figure out? So this is something really important. You need to look at something to figure out the sign. What do you think I have to look at to figure out the sign of the correlation? I hear it. It's not the graph, but it's kind of related to it. It's the slope. Very good. You need to look at the slope to know the sign of the r value. Well, this slope is positive. Therefore, it's a positive correlation. And yes, my r value then is positive 0.598. If you had a graph, you could tell from that, true. Okay, but we don't have a graph in our mini-tab computer printout. Okay, so then we reference the slope. Okay, I have not graded my afternoon classes quizzes. I have graded the morning classes quizzes, and the most missed item is the words used for r squared. So I'm going to take a moment and kind of talk about that real quick. So, here we go. I actually am going to type something. In context of the problem that was just right there on the previous page. So here on this previous page, our context is the height of the tree and the volume of the tree. Okay, so let's write this in here. I need to kind of get you out of just memorizing this phrase to understanding what this phrase says. So we had 35.8% of the variation in the volume in the tree is explained or happening because of the linear relationship between the height and volume. Okay, now that that's filled in, I want to discuss it with you to see if I can make it make more sense in your brain, not just this phrase you memorized. Okay, here we go. So this is saying 35.8% of that fluctuation in volume. Okay? Fluctuation in volume. The changes in volume that are happening in trees. 35.8% of the changes in the volume is happening because of there being a linear relationship between height and volume. Yes?
Is this like a predicted percent, or is this...
It's approximated, and it comes from a formula which is used from R squared. And so I kind of will talk later today about exactly that notion of R, where it comes from. So you can have an understanding of how this R squared comes about. Okay? So there's kind of some other words you could interchange in here. Maybe it would make more sense to you if you talked about like the fluctuation in volume or the changes that are happening in volume from one tree to the next. The differences, those different values of volume, it is explained by, or maybe you like to say, is attributed to. Okay, or maybe you want to say, is happening because of. Okay, so any of those things, are some terms that might be a little more layman's terms, more regular vocabulary to make it kind of make a little bit more sense. Okay, so 35% of that fluctuation in all of those different volumes of trees is happening because there's a linear relationship between height and volume. Well, what do you think the other part is attributed to? Why else would there be differences in volume? Okay, weather, so maybe it has more liquid or water in it. I don't know. How about density, type of tree? Density in the type of the tree. Oaks are a lot harder than pines as far as the trees go. How about the diameter of the tree? Wouldn't that have an effect on the volume, not just its height? Okay, so just 35% of that fluctuation is attributed to the linear relationship between height and volume. All right, the other part is other things. Okay, all right, so that was the weakest part of our quiz, is that understanding. That's it. So I've gone through, one last thing. You see this R squared adjusted? I don't know what industry uses that for. I actually don't know exactly what's making it adjusted, but we don't use that. We don't reference that, so don't let that be a value that distracts you, okay? Just use the plain R squared. Now, the rest of this stuff is just exactly what I said. I will tell you there's a typo on the top of this on top of the back. This is actually not the correlation of determination. R squared is called the coefficient of determination. Okay, so that was a typo. It confused somebody in my first period. So, and then this picture here is just in case I need to explain some more stuff, which I'm not going to. So, right now, I want to give you 10 minutes to start that homework part 2. And those of you who didn't get one, I'll go make some copies of that. Okay, and then we'll come back and talk together on, we'll start the Chapter 8, Part 3 notes so that we'll have it better done for tomorrow, and